Hello and welcome! In this lecture we're going to take our action code and refactor it to support a general take action method instead of requiring unique methods per each action. So now let's refactor our code to see a general take action method. In order to make that, let's go into the base action, and over here let's make that function. So make it public. We want to enforce that every action will implement this function, so let's make it abstract. Then we're going to return a void, let's call it take action. And now for the parameters, let's assume that every single action takes at least a grid position and the completed delegate. So let's receive here a grid position and also the usual action, so on action complete. Okay, so this is our generic take action method. Now let's go into the move action script and let's see our error. And the error is because we are not implementing that one, so let's do it. And the way we do it is let's just change the name of our move action. Let's change this to just take action. The signature already matches, we just need to add the override since we're overriding an abstract function. Okay, so that's it, no need to change anything else. Now let's go into the spin action and do the same thing. So instead of spin, let's call this take action. We need to override the base take action. And finally for this one, we need to change this so this one also receives a grid position. Now this one does not do anything with that grid position, but it does need to match the base function signature. Now like I said, this is sort of the downside with doing it like this. We basically have a parameter that we're not using in any way. Now this one is not necessarily a problem, it's just a little bit annoying to have a parameter that is never used, but if we want a generic take action, then we need to do it like this. Although there's actually yet another way to build this. If we had tons of actions and each of them with different parameters, we could still use the generic take action method, but in here for the parameter, instead of receiving something of type grid position, we could define some sort of class that we could override. So maybe on the base class, we could define some kind of class like the base parameters, something like that. Then for each action, you could make a class that extends that. So you could make a class, for example, here for the spin base parameters. Then you could change the take action to instead receive of something of type base parameters. And then here you could assume that on the spin action, you could convert that one, so base parameters, and cast it into a spin base parameters. Just need to ensure that this one extends base parameters. Okay, so this just to show you that there's yet another way that we could take multiple parameters while still having a generic take action function. My goal with this course is really to make the code super nice and extendable. I want you to be able to build any kind of game you can think of, so that is why I'm constantly commenting out on various possible ways to do things. But at the same time, let's keep things nice and simple so we can easily follow. So let's get rid of this one and go back to our original usage of just putting here just a grid position. So let's just assume that all of our actions do something with the grid position, and if not, just like this one doesn't, then we simply have a grid position that we don't use. Okay, so we have refactored all of our code, so the spin action has a take action, and the move action also has one with the exact same name. Now we can go back into the unit action system, and over here we no longer need this switch. We can just go into the selected action and call the generic take action function. So pass in the mouse grid position and pass in the clear busy. So because we refactored our code to make sure that all actions share a common take action function, because of that, then we can just call this instead of having to do all of these switches. However, here you might already be seeing another issue, which is that the spin action, sure, this one just takes an action. However, the move action requires that it's validated first. So once again, the solution is simply to just add validation to every single action. So let's go into the isValidGrid position. These are defined on the move action script. Let's put both these functions on the base action class. So let's copy this one, go into the base action, let's paste it here. And for this one, we can actually give it a default body. Let's see it in a bit. Let's just copy the other one. So let's go into the getValid. Let's go and paste this one. And for the getValid action grid position list, for this one, let's enforce all of the actions. Let's make sure that they implement it. So make this abstract. And for the isValid, we can actually just use this default behavior. So this is going to be common pretty much every action. So we just do this. So pretty much just call the function, which will be implemented on a per action basis. And then over here, we just use that function and just test if it contains this grid position. And if we want, we can even make this virtual, just in case there are some actions that require different logic on this one. But really the important one is that we implement this one. So let's first go into the move action. And over here for the isValid, that one exists on the base class. So let's get rid of it. And for this one, all we need to do is just add override. Okay, that's it. So the move action has no errors. Now let's go into the spin action. and over here we need to override that one. So let's actually copy that code from the move action. So let's copy the function definition as well as the creating the list. And on the spin action over here, let's push this. And here it can be pretty simple. Let's just make it so that the action to trigger the spin action is exactly where this unit is standing. So let's get a grid position for the unit grid position. We go into the unit and we get the grid position. Then we just return a new list. And this list will simply contain this unit grid position. Okay, that's it. Super simple. So we have now implemented two more common functions to our base action class. So we've got the isValid and we have the getValidAction grid position list. So now we can go back into the unit action system. And in here now we can do our validation. So before we take our action, let's test if this action, so if the select action, if this is a valid action grid position, and pass in this mouse grid position. If so, then we take the action. So now the code that we have here will work for both the movement and the spin action and any other actions we want. Let's just make sure to also call busy, and that's it. Okay, so here we see both methods. So the method using a generic take action and the one here using a switch. Let's get rid of the switch since we refactored our code, and let's see if just like this really nice short code, let's see if all of this is working correctly. Okay, so here we are. Now if I click, yep, there you go, the unit moved. Now I click to select the spin action. Now if I try to click, however, for the visual, we still haven't updated the visual to make sure that it uses the selected action. However, we did change the validation logic for the action. So if I try clicking outside of here, and nope, I'm not doing any spin. However, if I try clicking on the same grid position where the unit is at, if I click, there you go, it does take the spin action. All right, awesome. So all of our logic is working perfectly. However, we do have one issue remaining. Basically, if there's a valid position underneath these buttons, so let's click to select the move action. Now if I move the camera to make sure that there's a valid move position underneath the button, and I click on the button to select again, now ideally it should only select the move action and should not take an action because it's currently being blocked by a button, but if I click on it, yep, that happens. The reason is because all we're doing is testing for a mouse click, so we're not testing to see if there's any UI button under the mouse. So let's solve that. Doing that is actually pretty simple. So we only want to run these, both of these, if the mouse is not over a UI element. And we can test that by simply asking the event system. So let's go up here, let's add something, add a using Unity engine.event systems, event systems, not events. And with that, now let's go into our update. So we test if we are busy, we return and so on. Now after this, let's test if, go into the event system. Let's access the current, so that is the current event system. In our game we have just one, so we can use this. And then we can use the function is pointer over game object. If the pointer is over a game object, then that means the mouse is essentially on top of any UI button or UI image or UI element. If so, then we don't want to handle either unit selection or the selected action. So if this is true, then let's simply call return. So if the mouse is on top of a button, then it's not going to run this or this. Okay, so let's test. So here we are, and let's move the camera to make sure that there's a position under the button. So now if I click on the button, and yep, there you go, it does not take the action. So I can now swap out each action and everything works, but it no longer goes through the button. Okay, great. Now there's only two more issues here. The first one is on the grid visual. So if I change to the spin action, it does not update. So let's solve that. For that, let's open up our grid system visual script. And in this one, let's see what we're doing. And down here on the update grid visual function, in here, we're still going through the selected unit and getting the move action. Let's refactor this code to make sure that we use the selected action instead. So instead of a selected unit, let's get a base action for the selected action. Go into the unit in order to get the selected action. So let's actually expose that. So over here, let's do one. So public base action for the get selected action. And we just return it, return the selected action. Okay. So back in the script, let's get the selected action. With this, we have the selected action, and then let's call the common function. So again, yet another benefit of using a base function. We don't need to change any more code, so just this, since every single action always has this function returning the valid list of grid positions. Okay, so that's really it. Let's test. All right, so here we can see the visual for the move. So these are all the valid move positions. Now I click on spin, and yep, there you go. That is the only valid spin grid position. Okay, great. Now the final issue is the selection collider blocking the action. So if I have the spin action selected and I click on top of the unit, This means that I'm also clicking on the valid action, so if I click here, I really do want to take this action. But again, there's the unit collider on top, so if I click on it, then it's actually select the unit instead of taking that action. This is a pretty simple fix. All we want is to not select the unit if it's already selected. So in our unit action system script, let's go to where we're handling unit selection. So over here onto this function, we test for the mouse click, we do our raycast, we try to find if there's a unit under the mouse, and if so, we select it. But before we do that, let's test if the unit equals the selected unit, then this unit is already selected. If so, then let's return false so we don't select this unit. Okay, so with this, let's see. So here, let's select the spin action. Now let's click on top of the only valid position and also make sure to click on top of the collider. So if I click, and there you go, it does take the spin action. So it ignores that I'm clicking on a unit and just takes the action. Okay, awesome. So over here, we added some UI buttons to select what action we want. And we also refactored some code to make sure that this works with any number of actions of any type. The only remaining issue we have here is that we cannot see which action is currently active. There's no visual over here on the button, so let's sort that out in the next lecture.